Good morning, everyone. I'm Giel from HyMa-Tech, semester 6 project of the Han, and I am here with...
Peter.
Matthew.
Mihai and Zen.
Good morning, guys. Thank you. Peter, can you simply explain what your research is about?
Yes, I can. My research is about combining bio-based products with a recycled glass fiber polypropylene. Since recycled glass fiber polypropylene is weaker than the virgin equivalent of it, I thought I could use bio-based materials to up the strength a little bit, so it can compete with the virgin equivalent. So that's it.
Okay, thank you, Peter. Mihai, how are you doing?
Yes, I'm fine. How are you?
Good, thank you for asking. Can you introduce what your role has been in the manufacturing process
Of course.
this project?
So my main role was to research the manufacturing process that it needs for the material to go through and find the best one to, in the first part, to obtain a plate. Also, that means I need to research the material, that is PP with glass fiber. And in the end, after we found like a good formula for the flat plates to adapt it for the 2.5D mold we're gonna make, and also some parts with it.
Okay, thank you. Zane, how are you doing?
Good morning, Giel. How are you doing?
Good,
I'm
thank you
doing
for
pretty
asking. Can you give a quick overview of what you have been working on this part of the project?
Okay, so as the main goal for the project is to study design parameters for the material glass fiber reinforced polypropylene, we decided to start off with a mold design that has different shapes in it and different geometries to study what the effects of these features are on the material itself. See if the fibers will flow in different shapes, and that's it. So my main goal of the project was main part of the project was to design the 2.5D mold that will be used to study these different geometries.
Okay, good to hear. Thank you. Matthew, how are you doing?
Hey, I'm doing good. How are you?
Also good, thank you. Can you tell us what your role has been in the project and what you're focusing on?
Yes, my role in the project is to research the mechanical properties.
Put the mic a little bit down.
Hi. My role on the research is to research mechanical properties of the glass fiber polypropylene plates based on the different temperature being used pressing on it.
Okay, and the temperature, why was that important?
Every company, they have a certain desire for parts and materials they implement on their products, and it requires different parameters in the production process to achieve those qualities that they desire. In our case, it is the tensile strength, and to get a different tensile strength for the glass fiber polypropylene plates, I believe temperature is the one to go, is one to change.
Okay, thank you. Good explaining.
For carbon. Yes, I'll start off with my personal project. So as I said, my goal is to use bio-based products with recycled glass fiber PP. And we'll call it PP from now on, because polypropylene is really hard to say if you have to say it 1,000 times.
Okay, thank God for that.
Yeah. A recycled glass fiber PP is weaker than the virgin material. So I thought maybe I can enhance the strength with bio-based materials. And the material I chose, is best suited for this is hemp, because it is quite strong.
What made you choose hemp though, out of all the other bio-based materials that were out there?
I chose hemp because it is known as that it is as strong as carbon fiber. This is, however, not true because it comes it has 2/3 of the strength of carbon fiber, and it has 70% of the weight of carbon fiber. So it isn't as strong, but it also gets the job done.
And it is lighter as well.
Yeah, it is lighter as well. Yeah.
Do you think it will do a better job than the glass fiber?
I don't think so. But yeah, that has to be found out. But let me think about this. The recycled glass fiber, the fibers are a bit shorter, a bit more regulated, and that's why they are weaker than the virgin equivalent.
Okay.
And that's why I think with the structure of the hemp fibers.
Do you think like it will be more controlled during the process of manufacturing?
It will support it more in its strength and stiffness.
Okay, because from what we know right now, glass fiber is like going everywhere.
Yeah.
Yeah, in the place we made. So.
Yeah. It will be the glass fiber will be the same, but the hopefully during testing, by laying out these hemp fiber nets over the under the plate,
Yeah. Okay.
we'll hope that the fibers, the glass fiber follows these lines.
Would be nice.
Would be nice, yeah. And if not, it would always. I hope it stiffens up the plate, so it's a bit more stiffer. Since it loses a lot of stiffness because the material is recycled.
Anything surprising or shocking to you during your research on hemp?
The amount of time people ask what do the hemp suppliers do with the rest of the material, and where can I buy that?
Yeah, they're really hard to reach.
Yeah, I mean they're not that hard to reach, but the how they make their hemp material. I receive a lot of questions about it. What do they do with the rest material? Do they smoke it or something?
But can I ask you from where you can buy it? Like if the law or what kind of law you need to respect? Is something there or like who sells this?
Yeah, that's a good question. A company in Switzerland, they sell the hemp,
So it's
like
nice.
the stem of the hemp, but the rest, like the stuff, the THC stuff you can smoke or use in medicine, they destroy.
Oh.
So maybe we can cut them a deal that they don't destroy it, and we get.
Yeah, that's a good thing. We can get high producing the plates.
Yeah.
So yeah, it's like a safety thing. We can say.
It's a safety thing.
Yeah.
Is it illegal to use hemp?
The stem isn't illegal to use, but the smoking part is illegal in some countries. But the actual stem fibers used are used already within various automotive areas. For example, motorsports. The Porsche runs the GT4 championship with the GT4 RS Cup.
Yeah.
And they use hemp fiber pellet panels.
Oh, okay.
So that's pretty cool.
So what will you need to prepare for these tests that you're planning on doing?
The material. I will need material. And I'll just need to sort out the right parameters, right production parameters. And
Can I ask you what the company said? Like, you said them you want like hemp, and they say, oh, it's fine. Did they ask you what are doing with it?
Oh yeah,
they,
sure.
they like the project. They like how it was like this process.
Yeah,
the
I called the guy in Switzerland, it's a Swiss company, and he actually asked that as well. What we want to do with it, and I said, yeah, we are a Dutch University of Applied Sciences, and we want to do a few tests with it, whether it can strengthen up the material or stiffen it up a bit.
Okay, nice.
Yep.
Did you explain them the whole process?
Yeah, I explained it to him.
But not too much, not to steal.
No,
the idea.
not too much, not too
Yeah,
much.
okay.
But he was keen on sharing information with us too. They are doing similar tests at their company.
Okay, nice.
So we'll see what that leads to.
So, Peter, you mentioned production parameters, right? Will the implementation of hemp into the glass fiber polypropylene change them in a big way to maybe affect the properties of the glass fiber in compared to without the hemp?
Yeah. So what happens when adding a net under the plate? The moment of inertia shifts, while there isn't really actually that much material added. So you get a longer fiber distance, like the famous formula MC divided by Y, and it will be able to withstand more stress like that, more stiffness stress, more bending stress.
Okay, it's
Yeah.
because like all the forces on the plate are more distributed across the entire plate instead of just at one area with the short fibers, right?
Yeah, that's true. Yeah.
So will the hemp like be at risk of maybe degrading or burning during the production process?
The hemp is treated and graded to around 300 degrees, and our process our process temperatures are all under that temperature. So it won't be. There isn't really a risk, but yeah, I think because there is still a lot of temperature, it will change the hemp just a tiny bit, but that is what we need to find out.
You know what I was thinking about? Like we are now in the project shifting to a 2.5D mold
Yes.
right now. This can be done with this mold. Do you thought about that?
I'm sorry, I didn't hear the last.
Oh, sorry. Do you thought about doing this with a 2.5D mold also?
Not yet.
But do you think it's possible?
I think it will be more difficult.
Yeah.
Because of all the different shapes, and sometimes these radiuses are really small, and the hemp net is kind of thick, like 1 or 2 centimeters in diameter. So it won't be able to go
flow or to stay.
To stay properly within the small indents. But for some shapes on the 2.5D mold, I think it could be possible to test.
Yeah, that's interesting. I think like Zain, we can say more about the shapes of the mold.
Yeah, I wanted to have one last question real quick. You said the hemp raw is 1 or 2 centimeters when you place it into the press. Don't you think that's a bit thick, considering our products are mainly between 3 millimeters and 1 millimeter?
I don't think it is, because it will go halfway in the product. So you will only see like half thing. So it will only be half centimeter or a centimeter. Still, you have some hemp sticking out.
Oh, so the hemp will not be fully integrated into the plate.
It will not be fully integrated. It will stick out a bit.
I see. So the last question was about integrating the thing, and then Mihai asked me about...
like you can start with saying, follow back the question.
Mihai, what was the question you asked me? I wasn't... no, let me do that. Sorry, Mihai, what was the question you asked me earlier?
Yeah, I just wanted to know about the more specific of the 2.5D mold, because Peter said like it would be somehow harder to fit the hemp, but I want to tell us more about that. Not the hemp, but the specific of 2.5D mold and what we are gonna do it with it now.
Okay, so the goal of the 2.5D mold is to study what different, as I said earlier, to study what different geometries are possible to be made using this material for the future products. So, damn, what do I talk about?
Well, what do you mean about the future products? Like,
Okay. So, as an example, recently we had a visit with one of our companies. Can we restart this real quick? So, Mihai, what was the question you asked me earlier?
yeah, I was wondering how is the 2.5D mold, to give us more specifics, and how is like made.
Okay. So, as I said previously, the goal of the 2.5D mold is to so that we could find out what different design parameters are necessary for other companies to produce products using our material. So,
What different parameters did you find like interesting? Like,
okay.
what we are looking into right now?
Yeah, so we have a company that's our partner in this project called Kato. They produce parts using thermoplastics and other plastic components in general. And we use their products as something of a reference since we know they are interested in our material. So we would like to show them that they can produce products using our material with the same geometries as the ones they have already. So what we did is we had a company visit. We visited them and we looked at their different manufacturing processes and the different products they have available. And first of all, every product is basically comprised of just a bunch of small features and geometries that combine together in order to make an object. That's how any object is made.
Like,
What's
like the
radii,
features?
curves, fillets, stiffeners. There's just basic features that combine together to form a product.
Okay,
You
so
know?
yeah.
So we looked at the products that Kato has available, and we broke them down into each of the little features within them. Like, for example, they had a helmet product, which
Mhm.
was for, I believe, their firefighters. So they have in it indents of like 2 millimeters, as well as like radii of 3 millimeters, and a general dome shape, obviously, for the head that had a specific curve. And they have other products like suitcases that use stiffeners and ribs. So we took each of these features and created some sort of like a choice table list.
Like the most common ones.
Yes. So we took the most common features within all the different products they had and tried combining them all into one mold so that we can see if it's possible to recreate their products using our material.
Okay.
So,
What would you say is the most challenging bit of implementing all those features in one mold?
the most challenging part. Honestly, I'd say it's to get in order to get a real proper picture of what is possible to be made with this product. We need to have different. We need to have a bunch of different geometries in one mold, not just a curve or a radii. We need to also have stiffeners, fillets, indents, thickness changes, etc. So having all of that be implemented in a single mold with the dimension restraints that we have from our 3D printer, that was slightly challenging. However, thanks to brainstorming with our senior engineers and supervisors at the company, we have managed to get it all to fit into a single product.
And what additional technologies are you integrating into the mold now as we speak?
Okay, so one of HyMa-Tech's main attributes. Is that a good word?
I'd say
Main products is that they can make a semi-gyroid cooling structure
yeah.
that allows the most even cooling and heat distribution in just a mold.
Maybe
So-
it's difficult, but could you describe the gyroid structure?
Ooh.
Yeah.
Okay, this will be a
Flat plate with holes and
Yeah.
special.
So it's a water inlet pipe. Starts off going into the mold, and it splits off into two different tubes that intertwine with each other throughout the length of the mold, and then it comes out on the other side. And then we have a bunch of these inlet tubes on each on both sides of the mold to allow for the intertwining to have a more even distribution of water over a larger area. So the
Yeah.
more water, so that the same water goes over more area, it is more evenly distributed, and the heat is then cooled more efficiently. Like the product is then cooled more efficiently.
To better regulate the temperature.
Yeah,
Yeah.
yeah. Homogeneous cooling, basically.
Okay.
So we have that integrated into the mold, following the. What's really cool about this semi helix structure, that's not the word I used earlier, but that's fine, is that since it is mainly, it's only capable of being produced using metal 3D printing, it is also easy to have it follow very difficult mold geometries. So if the product you have is very intricate and very detailed, you can still have the cooling follow every single part of this product.
Yeah.
With an even thickness between the mold wall and the cooling all over the mold.
You
So-
said like our cooling is following the geometry of the mold,
Mhm.
basically. Let's make a clear image of how our mold it looks like in the end, like with everything. So
Yeah.
I have like the baseline is the structure,
Mhm.
the shapes, then what it is.
Yeah, so the main features of the mold, there are four main features. There's a cone, there's a thickness change, stiffeners, and corrugated sheet section. Each of these features are there in order to each of these features are there to study a different part of designing a product. So the cone is there so that we can study what the maximum radius is, or like rather than the maximum, what the fibers. Whoa.
Like what range of possibilities we have doing
Yeah.
So you said about that cooling is following the shape of the mold. Let's get an idea, like everybody to understand how our mold is gonna look at the end, like all of it.
Okay. So to give a general picture, there's first the product and then the inner mold line, which is the part of the metal that touches the actual thermoplastic and compresses it. Right above that is the helix cooling structure that I just described. And right above that we have induction heating, which will be used to regulate the temperature of the mold. And since there's both induction heating and water cooling, it is possible to really accurately control the temperature of the plastic as it's being heated and as it's being cooled. And Matthew, your main project is about the heating of the mold and what effects it has on the product process. Can you tell me more about that?
Yes. So we've tested with plates with pressed as with 200 degrees Celsius, and it showed promising results as the plate was fully formed into a square, which we intended to do so with a 600 by 600 millimeter picture frame, and we tried pressing it with a 100 degrees. However, there were short shots on one end, and it proves that there are more viscosity within the material, which means it's more dense and harder for the material to flow.
All right. Was there anything surprising or unexpected that has happened during the project?
Well, we expected that it will be rougher and harder for the materials to flow because of the cooler temperature, and the short shot was somewhat expected, but it was a much shorter production process because once it is pressed at 100 degrees, we could practically take out the plate from the pressing machine really quick, rather than waiting for a couple hours, 3 to 4 hours, for it to cool down.
Mm-hmm. What would it mean for if it with further testing would maybe work? What would it mean for automotive industry?
We will see on the tensile test. It will really depend on what and where is the material implemented into the vehicle.
Okay, so you're planning on doing tensile tests on the pieces, right? Are there any other tests that you're planning on making using the test pieces that you have produced so far?
Other than the tensile, we are also testing volume, seeing the
Fiber volume fraction? you mean?
fiber volume fraction, and see how much mass there are of fiber within this certain area on the plate.
What kind of car parts can you make out of these plates once we're done testing, everything goes well, we get a lot of money, and probably not because we're students, but what kind of car parts can we make with this process?
Glass fiber, polypropylene are commonly used on body panels for their light characteristics and somewhat structural integrities.
Mm. Yeah, I can see myself upgrading all my body pedals for.
Maybe I could make you some more when I have the spare time in the factory.
Yeah.
Just let me know.
Morning, beautiful people.
Back. Hello. So, Zane, can you tell me why that many flat plates?
Okay, so when we started with this project, we were very unsure about how the entire process really went. So we decided it would be best if we first familiarized ourselves with the process. So we started producing just a couple flat plates to see how everything goes, from the extruder to the oven to the press, the cooling afterwards, removing the plates. And as we kept producing, a fellow intern at the company told us that he required some flat plates to do some tensile tests, so we kept the test going. But then, so we made a couple of flat plates from there.
Okay, and has that also something to do with the manufacturing process, about the processes went?
Oh yeah, so Mihai's part was mainly about the different manufacturing processes. And
I can confirm that it was.
plans. So we used the flat plates as a template. Mihai, can you tell us more about that?
Yeah, I can do that. So my research was like trying to find the best parameters we can work with for production to make a good, let's say as good as possible flat plate. And what does that mean, as good as possible? We want to go closer to the plates that are already made, but not from recyclable materials. And the production looks something like you have the pellets that are made out of PP and glass fiber, and the glass fiber is like around 30%
Volume.
yeah
Fiber volume.
yeah volume, yeah. And we start the production by putting the pellets in the oven to get the humidity out of them. And after that, after 1.5 hours of staying in the oven at 110 degrees, we move them into the feeder from the extruder, and then they are passing through 3 stages at the extruder. We have the feeder, like it's around 200 degrees, then it's moving to the mid zone around 250 degrees, and then the end part around 240 degrees. After that, the extruded, the charge, is putting on the tray that is heated at around 200 degrees,
Yeah, I'd say so.
where we say we make a burger, because we kind of model the charge into a
Patty. Just
yeah,
a
in
burger
the patty, yeah, we
flipping it
can say
around.
that, and
Yeah.
flipping around to have to be heated on every side. And after that, after all the extrusion is done, we move to the press, where we put the charge in the middle. We took some measurements, and the middle is the best for our case in the flat plate. And then we put the mold, the charge, and press it. Also, I forgot to mention the plates, and the mold and the press plates are also heated at around 210 degrees.
So is it always 210 degrees, or did you change the parameters every once in a while?
We till we got the best value, we changed and experimented a bit. We can go a bit more higher, will be better, but also with these degrees we have a good result.
Yeah.
And
How
after, because we don't, sorry,
How did it went well? Did it went well when you just did not heated it up?
yeah, let's say
What happened?
it sticks to the mold, and
Yeah.
it's very hard to.
Took a lot of blood, sweat, and
Yeah.
tears to get
Yeah.
that plate open again.
But also we have
A lot of manual labor.
oh,
Yeah. Not fun.
yeah, not fun.
But on the other side, what do you think was the most fun?
Most
about,
fun?
The
producing?
release agent, maybe?
That one was the least fun thing. Yeah, I imagine we start the production having the release agent already applied on the mold, and we thought it doesn't stick so bad. So we didn't know at the first that we need a lot of release agents. So we just go in the production till one day we did a plate and it doesn't get out of the mold, and for 1 week we try to take it out and
Yeah.
scrape it. Yeah, I think you both know
That was an interesting week.
the
Yeah.
work.
We only scrubbed the plate
Yeah,
for hours and hours.
hours and hours. Yeah.
Yeah.
A lot of that small spoons went broken.
Yeah.
And brake cleaner.
So what part of this process do you find the most interesting and challenging part?
Yeah, I think the most challenging one is to find the right values for the production. And also I can say the nicest part was seeing that our production is doing good, seeing actual things being made.
Yeah, and getting consistent
Yeah.
products after a
Yeah.
while of failures.
Going from numbers and phrases to actual product in your hand and something physical, it's
Yeah.
great.
Yeah.
Yeah, that is true.
What would you say, taking in account of things that happened, was the main takeaway for producing those plates?
Yeah, I think the release agent was
Have stuff organized.
Yeah, I need to. yeah,
Yeah.
because after that we applied the release agent. We didn't have a good release agent, so it stick again, and then we applied a good one, but we didn't apply it correctly. So
Yeah.
the same story again.
Yeah.
But in the end, after 3 takes, we learned.
Yeah. What advice would you give to someone starting out a research-heavy project like this one?
Good question. Thank you. Yeah, it's also advice. I think a good advice will be not to be scared about the outcome, because it's a process where you learn and try things. So it doesn't need to be correct every time. You are not aiming it takes a lot of failures to achieve something. So at least in the research,
A failed product is still a good result
yeah.
Yeah.
for research.
Yeah, it's a good result if you also like to mention this. It will be like a great result also if you look into what it make it fail, like why it failed.
Yeah.
Because you just throw it is not going to anything.
So you're saying like don't be scared of failure because it teaches you more than
Yeah, I
if you
think
were to
this,
just succeed,
yeah,
right?
this is the important thing I think, because you are researching something, so you don't know at the beginning if it's possible or not. So
if we did everything right, we didn't learn something.
yeah, of course.
They will also say like when you're going one step back, you just get further.
Yeah.
Something like that.
Sounds like Johan Cruyff would have said that.
Yeah,
always
almost
think.
Johan Cruyff. When you don't have the ball, you can't score. So Zane, do you also know Johan Cruyff?
I don't watch football. I'm assuming he's a... Come on, man. At least let me finish the sentence.
Zane, about the 2.5D mold. How did you came up with the mold and why are the cone in it? So can you tell me something about it?
Yeah, okay. So at first we... the goal of the mold is to figure out what design parameters are there for making a product with this material. So we had to have some sort of mold shape that had a bunch of different features in it that could test the limits of this material. So at first we just kind of went at geometries at random, looking at what different shapes there are available.
Yeah, but
But
I think, sorry to interrupt.
Yeah.
I think we also look at some products from our partners.
Yeah. So
We say something about it.
near the middle of our project, we had a company excursion towards one of our products, Kato, one of our partners, Kato. And they gave us a tour of their manufacturing plant, all the different products they have and what they struggle with, what they don't struggle with. And that gave us like a really good guideline for what they need from us, since they're the ones who are planning to use our product. So once we had that guideline, we took samples from some of their products. Sorry about that. And we created like a list that broke down each product into all the features that made this product when combined, and took the most common ones. And then using the guidelines from the partners with what they struggle with and what they don't struggle with, we chose 4 features, which is a cone to study what varying radii does to the material and what the maximum curve it can take before like the fiber starts snapping or something else. We added a stiffener because a lot of their products happen to have ribs and bosses in it, made of plastic, and we didn't know what like the maximum pull depth is, how thick can the stiffeners be before they start sinking, etc., etc. So we have multiple stiffeners in the mold, as well as a thickness change, and just to see what the different thicknesses available to us are. And lastly, like a corrugated sheet section, because one of the biggest gripes that Kato had is that when they created a product that indented their fibers into like a wave pattern, I guess I could say, the fibers did not make it all the way to the top of the hump. Instead, they would just go straight over and there would just be matrix at the top, and that's not a good product. So we took all those features and we combined them into like one part to see what is possible, I guess. Yeah.
Okay, and that's also the main reason why all of the features like the cone, stiffness, and the thickness change has to be in one mold and not like in 2 separated.
Yeah. Also, it's a student project, so we don't have the budget to make 4 different molds for each feature. Yeah. But
No
so that's why
money.
we had it all indented into one.
Are we allowed to say this? But maybe how much is one mold?
Like price-wise?
Yeah.
I believe it's
It's
10,000 euros for half
more
of
than
one.
that. Yeah.
Yeah. Like
More
a
than
flat
10,000
plate.
euros.
A flat
for-
plate was 20,000 per half, I believe.
Yeah,
Jesus
but
Christ.
the
Yeah.
flat plate with the cooling.
With the cooling. yes.
Yeah,
And
with
we
the hard part, but it was like 25 everything.
Yeah,
I think both or just one part.
just one part. Yeah.
Oh my god.
So yeah, we definitely did not have the budget for 4 different molds.
Maybe
So
it's made out of gold. I suggest.
I would take it if that's the case.
Who's who's printing that for us?
Oh yeah, so since the cooling channels have a semi-gyroid structure inside it, they're basically impossible to make using purely just machining a piece of metal. So instead we contacted a company, K3D. They're also our partner and they're helping us with this project a lot. And they're going to be 3D printing just the cooling channels and the inner mold surface out of metal, and then that will be mounted to the rest of the mold, hopefully. And the rest will be machined by another partner company, Outslag, I think.
Yeah.
Oh, yeah.
So just the cooling part with the shapes.
Yeah.
Will be
Yeah.
printed. Yeah.
Yeah.
And then the induction and the support part will be machined,
Yes.
and everything would be not glued, but let's say put together and be
They'll be
mold.
mounted together. Yeah.
Yeah.
Bolts mostly.
Yeah, bolts.
Bolts. Yeah.
And that will be mounted to the press, and then we're gonna start production.
We
Yeah.
can,
That's basically it. Yeah.
Is there anything you would do differently if you have to start over? Are there any problems you...
Start faster.
Start faster and set probably, as our senior engineer Nick has mentioned, having the final deadline of when when not our team has to do a job, but when we have to contact other people for the job, we should set aside extra time for that because other people tend to be lazy
and slow.
So we should start earlier and set a set deadline for the last part.
Yeah, I think the one with deadline
Yeah.
should be a good idea.
Yeah. Set more internal deadlines.
Yeah.
Stick to it.
People management and deadlines. That's the main takeaway. I
Even
think.
more deadlines.
Yeah.
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 That's all
Yeah,
life
but
is,
we
series of
didn't have
deadlines.
like a lot of deadlines right now. We have like, okay, this week we need to finish this.
Just a weekly schedule.
Yeah.
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 Oh yeah. Schedule.
But I think like a date set that we assume we finish the mold, and then sometime before that we contact the partner to print it,
Yeah.
and they know on this date they need to print it. Yeah, would be a good idea.
Yeah, that would be better for everyone, I think, because
Yeah.
then everybody will know when they need to deliver.
Mm-hmm.
Yep.
Yeah.
Okay, great. So that's a good...
Takeaway.
Yeah.
Yeah. And what would you say, considering everything, was the most fun to do for you, Zane, for this project?
Probably when we finally figured out, because it took us a lot of time to actually like get started on designing the mold, because we didn't know what shapes we wanted to be in it and stuff. But once we actually got that down and I could start getting to work, I guess, making the part and then seeing it go from, a square on SolidWorks to a full mold with gyroid cooling and induction heating and all the mounts in it at once with the overflow channels and all that, and then it being sent to be printed, and 3 weeks from now having a final product. It's same as Mihai said, it's a very rewarding feeling having a thing
Yeah.
that you can hold, you know.
Waard voor je geld.
Mooi gezegd.
So one last question, guys. Do you prefer McDonald's or drinking a beer at Lokaal 99?
I think McDonald's.
McDonald's? Yeah. Should
Yeah.
we go for it?
I'm
McDonald's
driving.
and beer.
McDonald's and beer.
Yeah.
Okay. Then we should have a weekly planning.
Weekly McDonald's is a bit expensive now.
Yeah, not gonna lie, we can put it on the company maybe.
Probably because all of the hard work.
Yeah.
The beer as
for
well.
What did you say, Peter?
The beer as well on the company.
Yeah. Thank you for listening, guys, and see you at Symposium.
Yes.